I wanted to give a shout out to the folks in Pittsburgh, Harrisburg, Wilkes-Barre, and Philadelphia. I'm sorry you couldn't make the 15th anniversary event, but here's a short version of my presentation. The first point that I'm going to make is that the scientific case is actually relatively straightforward. It's not controversial, though there's some who would like you to think that the science of climate change is controversial. It's 2-century-old physics and chemistry. Literally, we've known about the basic physics and chemistry behind climate change longer than we've known the theory of evolution. So the fact that certain gases in the atmosphere, like CO2, warm the planet has been known for nearly 2 centuries. Joseph Fourier is the same scientist who discovered the law of heat conduction, okay, back in the early 1800s. He knew about the greenhouse effect, okay? So this is not controversial science. The fact that we're increasing the greenhouse effect by fossil fuel burning and other human activities, again, it's irrefutable. We've been measuring the buildup of these gases in the atmosphere. This graph that I put together a couple years ago is already way out of date. I have to add another notch here because we just passed, for the first time ever, the 400 parts per million CO2 concentration in the atmosphere. We think we have to go back millions of years to find CO2 concentrations that were that high in the past. So we are engaged in a truly unprecedented and uncontrolled experiment with the one planet that we have, the one habitable planet that we know. So, given what I've already said, the thing that I would not be able to explain to you would be if the planet wasn't warming up. I mean, it's basic physics and chemistry, irrefutable measurements that we're increasing the concentrations of these gases. What would stump the scientific community would be if the planet were not warming up as a result of this. And of course, the planet is warming up. It's already warmed about 1.5 degrees Fahrenheit. And you know, if you're a critic, and there are the critics out there, and you don't believe the thermometer records that we use to construct the record of temperatures back in time, I could show you dozens of other lines of evidence, independent lines of evidence that would tell an internally consistent story of a planet that's warming up and a climate that is changing much as we expect it to, as we continue to burn fossil fuels and elevate the concentrations of these gases. None of that was based on climate models, okay? You'll sometimes hear from the critics, oh, climate change, global warming is based on these untrustworthy models. It is doubly wrong, because it's not based on the models, and the models are not untrustworthy, and I'll get to that in a moment. It's based on, 2-century-old physics and chemistry and irrefutable measurements about how we're changing the composition of the atmosphere and how the atmosphere is indeed warming up and the planet is warming up. And that didn't involve climate models. It just involved very basic principles. But we do use climate models to perform experiments, to ask what-if type questions. After all, we only have one Earth. And as I said before, we're already playing an unprecedented experiment with that one Earth that we have. But if we want to test other possible climate histories, what would have happened if we hadn't increased greenhouse gas concentrations? What would happen if the only factors were natural factors that were driving them? We can ask these kinds of questions and try to address them using these models that embrace our understanding of the physics and the chemistry and even some of the biology that is involved in what we call the climate system. All right, now some of you will probably recognize that place. You're probably wondering why I'm showing you this Seinfeld restaurant. Well, 3 years before the Seinfeld show went on the air, in the upper floors of this building where I did a sabbatical about 7 years ago, I think it was, sits the NASA Goddard Institute for Space Studies, a climate modeling center in the Upper West Side of Manhattan, above Tom's Diner. And 3 years before the Seinfeld show went on the air, Dr. James Hansen of the NASA Goddard Institute for Space Studies in 1988 made a prediction. And as was famously said once by Niels Bohr, predictions are hard, especially about the future. And Hansen made a prediction about the future. He said, what would happen if we continue to burn fossil fuels and elevate greenhouse gases into the future using his climate model? There you can see is the warming that had been seen in the decades leading up to his experiment in 1988, and he ran his climate model 3 different times, and you can see that produces slightly different climate histories because there's a certain randomness to the climate system. But each of those simulations captures the overall warming that had been seen up to then. But he then said, well, what if we continue to burn fossil fuels pink, if we curtail our burning of fossil fuels? That's the lowest one. Blue, green, if we greatly accelerate our fossil fuel burning well beyond any sort of reasonable projection of business as usual. And then the blue, somewhere in between. And it turns out the history that we've pursued is the somewhat in between. In terms of our fossil fuel burning, we've pursued a scenario that corresponds most closely to that blue curve. So let's take away the other two. That was Hansen's prediction decades ago, and that's what actually happened. I would say a pretty good prediction, decades into the future. If you're a critic, you might point to this event here, 1991, 1992, where the climate cooled. The climate model doesn't pick that up. You might say, well, if these climate models are so great, how did it not pick up a big event like that? And it is true that Hansen didn't know that Mount Pinatubo would erupt in 1991, and it would put large amounts of particulates into the stratosphere that would block out some of the incoming sunlight for several years. But he actually did another experiment when that happened. He knew it would take about 9 months for that volcanic particle cloud to spread around the globe and begin to have a cooling influence. He had time to make another prediction. And he ran his climate model, he put in the estimated distribution of those volcanic particulates, and it predicted that the globe would cool by about 0.5 degree C for a couple years. Turns out it was another very successful prediction. So there are reasons to take the model seriously. They have been vetted. They have been validated. They've made successful predictions. So let's use those models to ask some questions. After all, we just saw that volcanoes, it's a natural factor, a volcanic eruption can cool the planet. So, maybe it's natural factors like volcanoes or small but measurable changes in the output of the sun over time that are responsible for the warming. Well, if we put those into the climate models, guess what? The models say the globe should have cooled in recent decades if we're just the natural factors, because we've had some big volcanic eruptions, solar output has been flat, you put those two factors together, the globe should have cooled. In fact, the only way we can explain the observed warming is when we include the effect of fossil fuel burning and the increasing concentrations of greenhouse gases due to human activity. So what about our future? What about projecting forward? Well, once again, we're not fortune tellers. We can't predict what human beings will decide to do. We can only say what we think will happen depending on what we do decide to do. If we choose to basically stop emitting fossil fuels now, we will avoid a net warming of about 2 degrees Celsius. That's +1 on this scale because we start out at about -1 in pre-industrial times. So at 2 degrees Celsius, that's a 3.5 degree Fahrenheit warming, would correspond to somewhere around here. If we stopped fossil fuel burning right now, we would most likely not breach that 2 degrees C warming, that 3.5 degree Fahrenheit warming. That's a threshold that scientists who study the impacts of climate change will tell you is probably where we start to enter into truly dangerous interference with the climate system. Not that we aren't already seeing dangerous impacts, but that's where things really start to get bad. We would avoid that. On the other hand, if we pursue business as usual, fossil fuel burning, we're more likely to be on that red curve. And there's some uncertainty in the models, and that's why you see some shading there, because not all climate models predict exactly the same amount of warming. They make slightly different assumptions about some of the underlying physics, slightly different answers. But we're talking 4 to 5 degrees Celsius warming relative to pre-industrial time. That's 7 to 9 degrees Fahrenheit warming relative to pre-industrial time. That's 14 to 18 degrees Fahrenheit warming of the Arctic. The Arctic warms about twice as much as the rest of the globe. So in that scenario, if we pursue business as usual and we warm the planet that much, then in the words of James Hansen, who I mentioned earlier, we will be leaving our children and grandchildren a fundamentally different planet. It will not be the planet that we grew up on. I do have some optimism, and I do think that we will, soon enough get on to the worthy discussion that there is to be had about what to do about this problem. There is a worthy debate that we can have about how to solve this problem. We can no longer have a worthy debate about whether the problem exists, but we can have a worthy debate about precisely, what technologies, what means of energy generation that we need to be considering as we make that necessary transition away from our reliance on fossil fuels. And I'm, again, optimistic that there are now Republicans who are arguing for sort of conservative free market approaches to pricing carbon, like a revenue-neutral carbon tax. And that's a great development, that there's now a movement from within the conservative establishment to look at solutions consistent with their political ideals, but that recognize the reality of the problem and the need to solve it. This is a problem as much of morality and ethics as it is a problem of science or a problem of economics or a problem of policy. To me, it's a problem of ethics, of intergenerational ethics. What sort of world do we want to leave behind for our children and grandchildren? And what this is about, it isn't just about polar bears in the Arctic. It's about a broad array of devastating impacts on health, human health, water availability, national security, food security. As I said before, if we proceed with business as usual fossil fuel burning, we will be leaving our children a fundamentally degraded planet. It won't be the planet that we grew up on. And there's an ethical obligation on our part to make sure that we don't do that. So I think, and finally, the point that I'll make is there is still time. There's a great urgency now to begin pivoting away from our reliance on fossil fuels quickly. If we're going to avoid that 450 parts per million CO2 in the atmosphere that's likely to give us 2 degrees Celsius warming of the planet, 3.5 degrees Fahrenheit, dangerous interference with the climate system, potentially irreversible changes in our climate, then we don't have time to lose. We need to bring our emissions to a peak now. We need to ramp them down several percent a year. It's not going to be easy to do, but the converse, the alternative, is unacceptable. It's the line earlier about we're headed towards the cliff, and you don't argue, well, it's going to cost us too much if we put on the brakes. We have to put on the brakes, or we go off that cliff.